Hey there YouTube, Superbrain AK here, and my apartment complex has a central heating and cooling system which is controlled by these controls. As you can tell, these probably date back to the early 70s. So that poses a few problems. One, the hysteresis of it turning on and off. Second, the ambiguity of what temperature is it actually? Well, I don't know. This is nowhere near calibrated. So, what I took the liberty of doing is adding a digital thermostat in parallel to the thermistor in there. So, you can still turn it off and change the fan speed with the original controls. It's just digitally enabled. So, this digital thermostat actually has two thermistors, which is very useful in this specific scenario, because how central heating and cooling works is they have a big giant industrial air conditioner that heats or cools water, and that water is then circulated into each apartment. So, the only thing I have control over is the fan speed and whether or not the thermostat is set to cool, turn on to cool, or turn on to heat. Now, with the second thermometer that the thermostat has, I'm able to tell if the system is on heat or cool, or currently nothing. How that works is I've got a wire running up into the ceiling here, into the duct grill. This hinges down, and that thermistor is touching the outlet pipe of the water, so I can know if the water's flowing and what temperature. So currently it is at 78 degrees and the interior temperature is at 75, so it's pointless to run the system. So that's why I have the system set to off. Now, during these in-between months where they don't have it set to cool or set to hot, and it's relatively warm outside because it's Arizona, of course. So I have to resort to other methods of cooling, which you may recognize from a really old video. So let me show you what that is. So here is my window in my room, and you might be able to see we have 4 computer fans in the window. And these are Foxconn something or other model number there. I'll put it in the description. But each of these are 150 CFM, cubic feet per minute. And there's 4 of them. So that is a total of 600 CFM, which is probably quite adequate for my room. So, how those are wired is, well, first off, they're bringing cool air into my room. I have a digital weather station monitoring the air coming in. And the 4 fans come down to this board here, which has a capacitor and some terminal blocks, and then that goes to this 4 conductor wire. So all the fans are in parallel, then the positive and negative go on 2 wires, and then the PWM, which is the blue wire there, goes on to a 3rd conductor, which is this white one, and so that brings the PWM across that wire. So I'll give you an overview shot of my room. Bed with monitor, nightstand with the DC buffer power distributor, 6-string bass guitar I got for Christmas. An electronics bench that is cluttered. Power hub. And closet and computer. So, the fans are over there. There's a wire running along my window sill. Pops out here. And comes around to here, onto my desk, and comes down to this board right here. So there you can see the positive, the negative, and the PWM. So this little board is a board that I put together on some more perf board. That was perf board over there as well. This board gets its power from 2 wires here, going down behind where other magic is happening. And it eventually gets 12-volt power from this Dell power supply from their really old small form factor back of the monitor computer towers, basically the first ones. And it is a 12-volt 18-amp power supply with a proprietary connector. But I've got an adapter back there soldered on with the XD60 output, and it is also powering a Class D car amplifier, which is powering my 2, technically 3 sets of speakers, and this speaker is not connected. So there's a Class D amplifier, and over here on the control board I have those connections here. So there's power, and then there's also enable. So if I were to flip this switch, you can see the red LED on these SGL8022W boards. I think that's right. It's got the 5 volts, so if I switch it off, it turns off. And you can see the power supply is in standby. So, switch it back on. Also, this switch here is the mute for the speakers, for the amplifier back there. And that goes to the main 12-volt enable remote, whatever you want to call it, of the amplifier. But what we really want to know is how the fans work. So, we actually have 2 fan circuits. Not sure if you noticed this guy right here, but he is also plugged in and an extension here. And so we have these 2 switches, which are the same kind of switches as these. And these do control these 2 PNP transistors. So 12 volts comes in here, goes to a capacitor, goes to the PNP transistor, comes out into a capacitor onto the line. And then the other one goes through the other transistor to a capacitor. So this transistor, then this capacitor, and then out. And so I've got some big resistors to drop the 12 volts and do a few milliamps of current to activate the PNP transistors. And so those are on and off on these switches. Ta-da! I switch it off, and it's off. So that's the 12 volts going to the fans, and then the PWM is handled by these two modules. Those get their 5 volts from this recycled board here. This was cut out of a TV board. Not sure how well you can see there. I'll post the control chip in the description. But it is asynchronous. I'm not sure if you can see both MOSFETs there. But yeah. So that takes the 12 volts down to 5 volts and feeds this board and whatever I plan on building there. So the 5 volts goes to the PWM module, and then I have a transistor inverting that because this is active low, so the PWM would be inverted, so then I need to invert it again. You've seen me talk about these, so reference one of those old videos. So I can ta-da! Medium speed, or off, or on at the same speed because this is still on, so the PWM stays. And then I can also change the speed of this guy using the other touch control module. So there we go. That's how this module works, and it works really good. So, not sure if you guys remember the old video, but that is in a card up in the description right now of my attempt to make a fume extractor, which worked pretty good. I know it's a really old video, so bear with it, skip around. But definitely move some air. And I don't know if my room is actually any bigger. Might be a little bit bigger. So that is air coming in. What about air going out? Well, I'll show you that too. So, air going out is in the opposite side of the house. In the kitchen, that one doesn't open, but this one does. Got an aloe plant growing in here. And then in the actual kitchen sink, we also have a window with a screen. So that could be our outlet, but we also have a better outlet for the hot air to go. So the outlet is actually in another room, the second bedroom, which is not mine. We have 4 more fans, and I cut up this extruded aluminum here and mounted the fans to that. The other fans were actually held together in my room with twist ties. Very well, I might add. And that is handled by another 12 volt power supply, 5 volt regulator, linear regulator, and an SGL 8022W. So, very similar, just a little more simple. Because it doesn't need to control on and off, because you just unplug the power supply because it's the only thing it's powering. And the reason why this room is our outlet is because graphics cards. Yeah. Not my thing. Fans pull the hot air out. And so my room is intake, this room is outtake, and the rest of the apartment is just pass through, whatever the difference is. And I can switch my room to be outlet as well, depending if I'm testing a power supply or not, like I tend to do. So, I hope you all enjoyed this fun little video of how I keep cool in the mid-months. And hope you guys have some good ideas for doing projects yourself with old computer fans. These are salvage out of old Dell computers. And just, if you see a problem, then find a solution for it. And you'll be all the bit happier. So, thanks for watching. I hope you guys have a wonderful day. And I'll see you guys in the next video.